I'd like to open up by telling a little bit of a story about myself, something that happened to me in college. I studied engineering, mechanical engineering, when I was in college, but I can remember the first chance I got, I took an elective class in geology because I've always loved geology. And I can remember that first day of class. It was held in a great big lecture hall, with a seat sloping down and real wide and the little flip-up desk. And down at the bottom, there was a chalkboard that went all the way from one side to the other. It must have been 25 or 30 feet long, this chalkboard. And I can remember when it was time to start class, the professor came in, and he came in through a door down there at the bottom, way down there. And he didn't say anything. He just kind of came in off to the side over here, and he picked up a piece of chalk, and he started drawing a long white line on the chalkboard like this. And he just walked along there, and everybody got settled in, and he was getting everyone's attention. First day of class, geology class. And he got to the end, and everyone was watching him by then, and he said, "This is the age of the earth." And then he drew two little lines at the very end, like this, up and down, right next to each other, just a quarter of an inch apart. And he said, "This is how long mankind has been on the earth." Now, if you've been a kid like me, maybe 19, 20 years old, maybe going to Sunday school and learning about creation in the Garden of Eden, what do you do with something like that when a professor says something like that? Is it true that the earth is billions of years old? Well, there's not really any proof for that. And biology classes are similar, maybe worse, huh? Is it true that all of life on earth is descended from a single common ancestor way back in the distant past? Well, the evidence doesn't really support that. We're going to talk about the Genesis account of creation tonight and evolution. And my objective tonight is pretty simple. I want to equip all of you with some pretty big questions for evolution, 5 big questions, challenging questions, because I've found in my own experience when we try to talk to our friends about this very sensitive subject, right? Family, extended family, we don't want to get into arguments or fights or anything, so one of the best things I've found to do is just ask, well, what do you think? And invite them to explain what they believe and why. And as they talk about it, they might offer something on the table, and you could ask a question about it. And one of the best things we can do is just ask a question in a way that will give them something to think about, kind of put a stone in their shoe, perhaps. And then just leave it at that without doing very much arguing. We're going to talk about the bias that we tend to see in science for evolution. We're going to talk about, not that guy yet. We're going to talk about information and natural selection. We'll wrap it up with a little discussion of the age of the earth and what kind of evidence the fossil record gives us. And then end by talking about why it's important. And I might as well tell you now that considering what's going on in science out there these days, evolution is in a lot of trouble. Did you know that? And there is absolutely nothing wrong at all, considering the science, with the Genesis account of creation in 6 days about 6,000 years ago. And I know there's a lot of different opinions about the age of the earth, and I'm going to talk about that a little bit later. But I believe that that's what the Bible teaches. And in case you didn't notice, there's an article on the back table that'll explain that a little bit. And that's also referenced in your notes, so you can see that online. And if you want any of that stuff sent to you, just sign up on the sign-up sheet back there, and I'll email it all to you. Okay? Now, evolution is a theory, even though it's kind of in trouble. But what always had me interested and curious was that everywhere we seem to look, it's a fact. Has anybody else in here besides me noticed that? Yeah. On the radio, news stories, we see it on the Discovery Channel, we see it on the National Geographic Channel, we see it in National Geographic magazine, everywhere, in all the news stories, the textbooks, high school textbooks. Why? Why do we see that it's really a fact when really it's still a theory? Well, the short answer is this. If there is no God, evolution must be true because it's the best explanation as to how we got here. If there is no God. And there is no other similar theory like it that can compete with it, so people are generally assuming that it must be true. It kind of has to do with the rules of science. Because when we do science, we're not really supposed to talk about God as a cause for anything, are we? And any scientist will tell us that. Richard Dickerson, UCLA professor of biology, has said, you know, science is fundamentally a game. Let's see how far we can explain the universe in terms of purely physical causes without invoking the supernatural. And there's a name for this. It's called naturalism. Naturalism is just a philosophy that says, look, as far as we're concerned, nature is all there is. There is no supernatural. There is no God. And we need to understand that science these days, our science is based on a foundation of naturalism. It's a presupposition, which is fine for most kinds of science, really. If we're doing experiments in the lab, what we would call experimental science or operational science, we're dealing with things that happen in the present. We can observe them, we're repeating them, we're testing them. This is what the scientific method is all about. And this is okay, you know, where we come up with a theory and we vigorously test to see if it's true. For example, what temperature does water boil at sea level? 212 if you live in America, right? Or 100 C. Yeah, I mean, any of us can do an experiment to test that. We can do it tomorrow and next week, too, to repeat it and gain confidence, huh? But what about when it comes to investigating something in the past? And it's really important to understand that there are two different kinds of science. Did you know that? With historical science, we may be looking at something that happened a long time ago, but there was nobody there to see it happen, and you can't do any experiments to repeat it. How long ago did the Grand Canyon form? How long? You've seen this before, Pat. How did the peacock get its feathers? Who knows, really? We could speculate, right? Now here's the really important part of this. So here's the hitch, and I'd like you all to get this. When most scientists move from the laboratory doing experimental science to investigating the past, they bring their presupposition for naturalism with them, and it's a bias. Okay, we're doing experiments in the lab, we're doing chemistry today. On Tuesday, we're going to work on our other project where we investigate where we came from. We're scientists, we believe in naturalism, natural causes, so there must be some natural cause for human development, right? A good example of bias like this is a courtroom. Poor old Harry over here has been shot. And we have Fred over here in custody in jail because we just know that Fred did it. Why? Because everybody in town knows that Fred never liked Harry. That's why. Besides, Fred's always been the town troublemaker. Now, we just got a call from the forensics lab back there telling us that, they're telling us that the bullet found in Harry doesn't match up with any of Fred's guns. But we're just going to ignore that evidence for now because we know if we go out into town and we talk to a lot of people, we're going to really find out that Fred did it. What's wrong with that? There's a bias there, huh? And I would say that's what evolution is. Evolution is just a story of what could have happened if there is no God. Okay? It's a story first if there is no God first. Charles Darwin made the story popular when he published his book in 1859. But he got the idea from his grandfather, and his grandfather got it from the ancient Greeks. So evolution in one form or another goes way back a long time. All right, now, how many of you have heard something like this? Well, if you believe in creation, you're believing in God, so that's religion over here. But evolution is science. In fact, over here in science class, we're studying evolution and we're just looking at the facts. Does that ring a bell with anybody? In this class over here, for any students, You can believe what you want, but in this class in science, we're just looking at the facts. Well, I would say, aren't we all looking at the same facts? Or I would rather say evidence. Okay? The fossil is the evidence, but how it got there is the fact. And different people are interpreting the evidence in different ways into facts. Let's look at a couple of examples because I think this is really important. These shells on the beach are the evidence. Okay? Well, we know that those are little animals. They're clams. We know they live in the water. We can even see the water. And when they die, we know from experience that their shells can wash up on the beach. Probably just happened about a week or so ago, or else they'd be buried and washed back out to sea, right? Not too hard to convert that evidence into a fact that most people would agree with, huh? Well, what about this one? Well, we know that since the Earth is billions of years old, that's enough time for that in that area of Arizona for the wind that we see there to gradually blow away. Now, wait a minute. Did you see it? Did you catch it? Since the Earth is billions of years old, I've got a presupposition there, don't I? I'm going into this with already preconceived notions that the Earth is very old. And since it's very old, then a little bit of rain and wind, and that's enough time to gradually blow away that dust and dirt until all we have left are these extra hard rocky towers. Or we also know that a huge amount of water can cause that kind of massive, large-scale sheet erosion in a relatively short period of time, leaving these erosional remnants. Can anybody here think of some big catastrophe that might have happened in the past, where there was a huge amount of water draining off the continents into the seas? Yeah, Noah's flood. So we need to understand that the conflict is not with the evidence. We're all looking at the same evidence. It's all on the table right in front of us from all around the world. The conflict is how different people are interpreting the evidence into so-called facts. And what can be a little irritating to some of us is how some of them claim that they don't have a bias when they do. We're just looking at the facts. You see how that works? Okay. Now, it's important to understand that we as Christians, we have a bottom line too, though, don't we? We'll admit it. We happen to believe that the Bible is from God and perfect, and that what we read in Genesis is an historical account that's reliable and true. In other words, we've just chosen to take God at His word. Okay? But I would say there's something different there. We're allowing for naturalistic causes plus the possibility of the supernatural, whereas the secular scientist is excluding the possibility of the supernatural and just looking at natural causes. All right. So the conflict is not with the evidence. So first big question for evolution tonight would be, how do you know that? When someone throws a claim out there to you or a statement, you might be looking at a fact that's been interpreted. You may not be looking at the evidence. So try to determine if it's evidence and it's been interpreted into a fact through somebody else's lens of their worldview. And of course, the follow-up question would be, could your source be biased? Because there's a lot of sources out there, TV programs, magazines. We just need to understand that many of them are going to be biased for naturalism only. And just keep that in mind, when we learn about these things. Okay, let's take a look at information and natural selection. The double helix molecule of DNA was discovered in the 1950s, and we now know that DNA is an extremely sophisticated digital code. It consists of 4 letters and contains massive amounts of information. There's enough information in each one of your cells to fill up a whole set of encyclopedias 3 or 4 or 5 times over. And what kind of information are we talking about that's in DNA? Well, it's coded instructions on how a given organism is going to grow and develop and build its body structures, like bones, muscles, nerves, hearts. So depending on what kind of organism that is, we know that when it's developing, it will go to that code and extract it and use it to develop, whether it's a redwood tree or whatever. Now, if evolution is true, we went from simple to complex, it must provide some process that can generate the information in all of life on Earth that didn't exist before. It must have a process for building up information from simple to complex. In other words, how could we have gone from a single-celled bacteria-like creature to a horse with all of its novel genetic information required for everything that is in a horse? All right, let me tell you a true story. When Darwin was just 22 years old, he got on the HMS Beagle and headed for the Galapagos Islands. And when he got there, he was studying a population of finches. And he noticed that the finches could have different kinds of beaks. And he also noticed that in drought years, the birds with big, strong beaks tended to do well, better than the others, because the seeds they ate got extra hard. And he noticed that after several years of drought, the only birds left in his population of finches were birds with big beaks. And he thought, you know what? I wonder if these kind of little changes as animals adapt can add up over long periods of time to be big changes. And so Darwinism became the idea that you have this kind of natural selection as animals are adapting, and lots of time, enough time, and you can actually go from one kind of animal to the next. And that's what he published his book about. That was his theory. But, still true story, at the time of publishing, Gregor Mendel, who is considered the founder of the science of genetics today, was just getting started with his experiments on how that kind of natural selection really works, and how traits are passed down from parents to children in generations. And we all know this now because this is common knowledge. It's taught in our schools, but I want to review because this is very important. Okay, suppose we have a breeding pair of dogs, and each one of those dogs happens to have the genetic information that will code for short fur. We'll call it the short fur gene S. It's a gene. But they also happen to have the genetic information that codes for long fur, both of them. We'll call it the L gene. So those dogs may have medium fur. You see that? Now we all know that if these dogs have puppies, that their pups could inherit any possible combination of those genes, right? Some will be like their parents and get L and S in combination and have medium fur. Some will get only the L gene in combination, 2 L's, and they'll have long fur. And some will get 2 S's and they'll have short fur. Okay? Now, what happens when this growing family of dogs moves up to northern Canada where it gets very, very cold in the wintertime? Well, any of the dogs that have medium fur, short fur, they're going to say, this is crazy, we're moving down to Mexico. And they're going down to Cancun, right? So very, very quickly, what do we have up in Canada? We have a group of dogs that only has long fur because they stay behind. Now let me ask you this. What happened to the short fur gene, S? Huh? Pardon? It's still there. It can be for a long, long time. But what I'm getting at is that you give it enough time and that population of dogs has lost it. It's going to be selected out. And scientists began to understand that, hey, Darwin was wrong. If anything, when animals adapt in different habitats, they're losing genetic information. His finches had the information for big beaks all along. They just lost the information for the other kind of beaks. And so they knew, the Darwinists knew, well, we still need a process that can build up information over time. And in the 1920s and 30s, it became mutations. The X-Men, right? Hey, the movies aren't bad. If you haven't seen the movies, they're okay. My son TJ and I have been watching them. I like science fiction. You know, it's fun. But the problem is that we now know that mutations do not build up information either. All they are is copy mistakes when DNA is copied from one generation to the next. Nevertheless, the new Darwinism was that every once in a while a mutation will come along, and natural selection is still there. It'll keep it if it's good, and it'll get rid of it if it's bad. And we can have evolution from simple to complex that way. But again, they're just copy mistakes. And since the written English language, since DNA is a code, like English, then we could use the written English language, this sentence, as an illustration. To be or not to be, that is the question. All right, suppose we're going to copy this, and a mutation comes along, and we've swapped a letter. Do you see that? There's different kinds of mutations. Some might come along and kind of swap a word in the DNA, or some of them will just delete a whole phrase, so to speak, in the DNA, a segment, and copy it again. But can you see that when mutations come along, we're not adding any new information to the sentence? Mutations gradually corrupt the DNA over time. Now, interestingly, there can be such thing as a beneficial mutation. The classic example are beetles that live on a windy island. Every time they get up to fly, they get blown out to sea and they die. But a mutation comes along and it damages the genetic material responsible for their wings developing. They stay on the ground and they live and they do well. And that's okay. They're adapting to their environment there, but they're starting to look a little bit different than their cousins on the mainland now, aren't they? But are they evolving into a super beetle? No. Because they've lost genetic information. They've lost their ability to develop their wings. Bacteria resistance to antibiotics is another example. A mutation has come along which has prevented that bacteria from having the ability to be sensitive to that poison. It's damaged its ability to transfer that poison molecule through the cell wall. But do we see bacteria evolving into something big and scary and new? No. No, they're losing information. One more example, there's a lot of interesting mutations in the domestic dog breeds because they've been bred on purpose for these things. Dogs like pugs that have the flat faces, that's a mutation that has damaged their ability to grow their muzzles out properly. But what I think is interesting is that it didn't damage the skin development, did it? That's why when pugs are full grown, they got a lot of extra skin there with all those cute wrinkles. Dr. Lee Spentner, in this book, he's just a world authority in this area on mutations. He said, in all the reading I've done in the life sciences literature, I've never found a mutation that added information. He says, information can't be built up by mutations that lose it. A business can't make money by losing it a little at a time. Okay? So even though there can be beneficial mutations, and that's okay, there's no way that a mutation or mutations can get us from something like a salamander-like creature to a red-tailed hawk. Imagine the new information and new body structures that need to come from somewhere. Well, let's take a look at the creation model now. We don't believe in a tree of life, we believe in an orchard. Because I think in the NIV translation it says 12 or 13 times in Genesis 1, each according to its kind. We believe that God created original animal kinds with huge amounts of genetic information to begin with because He would want them to go out and adapt to various habitats and environments and survive. It's estimated that there were about 8,000 original land animal and bird kinds, and all of the land animals and birds that we see on the earth today would be descended from those different kinds that may, look a little different within their kinds due to adaptation. Let's see how it works. Let's look at the dogs, for example. It's estimated that there was only one original dog kind nowadays. We have evidence genetically that would point to that. Probably looked a lot like a wolf. Okay, so God creates the dogs, they have a family, they grow, they might go out and diversify and they might start adapting in different places, and along comes the flood, roughly 1,500 years after creation. Noah, all the animal kinds are saved on the ark, right? Noah didn't have to go out and find them. God supernaturally called them on the ark. Do you remember that? Flood lasts a year. The dogs, that pair of dogs gets off the ark and they start a new family and they grow and they split up and they diverse. Some of them wind up in northern Canada and some of them wind up in Cancun. And what do we have today? We have wolves, we have coyotes, we have dingoes, we have jackals, we have foxes, not to mention all the domestic dog breeds. But let me ask you the question. Are we seeing information gain in the dog kind or information loss? Loss. As those different groups of dogs are going out, they're losing information as they adapt in different places, and so they're starting to look different from one another, aren't they? Let's look at the primates. I don't know how many original primate kinds there could have been, but same thing, they get on the ark. Afterwards, they grow with families and they split up. But can you see that a lot of them don't make it? You can see that in the illustration. We know that from bones that we find, by the way. How about the dinosaurs? Well, if we're going to take Genesis seriously, then the dinosaurs would have been created on day 6 with all the other land animals, wouldn't they? It's estimated that there were about 30 different dinosaur kinds that were saved on the ark. Same thing, they get off the ark, they multiply, they split up, they start to adapt, none of them make it. Various theories why. But can you see that there is absolutely nothing wrong with natural selection, adaptation, and even mutations in the creation model? In fact, it's a pretty important part of the model. So there's no problem with adaptation and information loss. Next big question for evolution, the tree of life, would be, where does all the information and DNA come from? Now, interestingly, what we still see in the textbooks is that we get evolution from natural selections plus mutations. But we now know that neither one of those can add any information. But that's what we keep hearing, and that's what's keep being taught. Why? Because there's no other answer. But the idea today is bankrupt. Okay? In fact, you look in the high school textbooks and you'll see examples of evolution in there with different animals. But if you look at it carefully, they're all great examples of natural selection. There's no example of information gain, yet there's an unspoken, unwritten assumption in the textbook that little changes will add up to big changes over time. That's what Darwin thought. But we know he was wrong. All right, let's take a look at the age of the earth now. The age of the earth is generally derived from these rock layers that we see all over the world. They're assumed to be millions and billions of years old, put down by very slow and gradual deposition. And that's because geologists are making an assumption that all of the same forces at work that we see on the earth today are responsible for shaping the earth in the past into what we see today. You see, they don't want to say that there could be some huge catastrophe back in the past that they haven't seen with their own eyes. Forces like rivers moving sediment along the landscape, or frost and ice weathering rocks. But believe it or not, other than this assumption that's being made, there's very little reason to believe that they are that old. The biblical view would be that most of these layers were put down by Noah's flood. Because a flood like what we read about in Genesis lasts a year. Now, something like that would have removed huge amounts of sediments in some places and redeposited them in other areas. And in doing so, it would have buried a whole bunch of different plants and animals, creating the fossil record that we see today. And if you think about it and you look at fossils, many of them are very good evidence for rapid burial. Because fish, when they die, they float to the surface, don't they? They don't settle down and get gradually covered up. And animals will get eaten by scavengers, or they'll rot before they have a chance to get covered up. So fossils are very good evidence for rapid burial. And if that's the case about the fossils, then what would that tell us about any rock layers that contain a lot of fossils? It would tell us that they were probably laid down pretty quickly because those plants and animals were getting smushed. Well, there is little reason to believe they're that old, except that evolutionists will point towards rock dating methods to support it to support the idea of deep time. So I want to go into rock dating methods just a little bit, not get too deep, so you have an idea of what this looks like. When geologists are looking at a rock, they can't measure an age. They can't measure that, but they're looking at chemicals that are in the rock. You see, interestingly, when you find a rock, you might discover radioactive elements inside it that are in the process of changing to another element. And an hourglass is a good illustration of this. They might look at something like uranium changing into lead, or if it was something that used to be living like a bone, they would look at carbon-14 changing into nitrogen-14, but the principle is the same. Okay? Now, scientists can very accurately measure these materials. We'll call it a parent material changing into a daughter material. All right? They can very accurately measure those materials or the ratios with very sophisticated and expensive machines. And you would think that if they can measure those and they know the rate of change, then they can calculate back in time how long ago it was that there was only parent material in there for that radioactive element, presumably when it changed from a molten state. So that's what they're doing, but when they do that, they need to do the calculation with three big unprovable assumptions, and it's really important for us to understand this. First of all, they need to assume that the amount of parent material and daughter material is known at the start. They need to assume that the decay rate has always been the same as what's measured in the lab today. And they need to assume that in the rock there has been no contamination of any parent material in or out, or any daughter material in or out. Now, scientists are investigating this, and it gets a little bit technical why there are problems with these assumptions. So I'm not going to go into it, but all we really need to do is look at the results of radiometric dating to understand how this works. And one of the things that we have is we've done radiometric dating of rocks that we know how old they are. For example, many of you remember when Mount St. Helens blew in Washington in 1980. They took rocks from that explosion and they dated them at 4 different methods. And they came back with results of 350,000 years, 900,000 years, 1.7 and 2.8 million years when the samples were just 10 years old. That's a big error. Why? Another example, in New Zealand, eruptions from the years 1949, 54, and 75, giving date ranges between 270 and 3.5 million years. The other thing that we see is when we see conflicting dates, and we know that there's a problem there, either one or the other or both are going to be wrong. Example of that, in Australia, wood that has been fossilized, and it's encased in a lava flow. But the fossilized wood dated at 45,000 years, and the lava that's surrounding it, 45 million years? How can that be? Grand Canyon. Rock at the top has been dated at 270 million years older than rock way down at the bottom, where you would expect it to be a lot older, wouldn't it? Over 250 million years difference? What in the world is going on? Well, look, when you research it a little bit like I have, you find out that results come in all over the map. And typically what geologists will do, or paleontologists, fossil scientists, when they're working in a certain area, they'll take many different samples all around the area, and they'll send them all out to the lab for analysis, and when they get the results back, they'll pick the results that best fit what they think is going on in the area. So you see their presuppositions and their biases coming into play, and that's the number that you see printed in the newspaper article. And isn't it interesting that we don't see anymore that scientists estimate the age of the skull to be 200,000 years old, but the age of the skull is 200,000 years. But we need to understand that these are just estimates. And they're rough estimates, and radiometric dating is pretty unreliable. We know that from the data. And we know that if it's not reliable, it's definitely not proof, is it? Okay. Well, along with these problems with radiometric dating, there is just all kinds of evidence out there that causes problems for millions of years. Like in the courtroom, the forensics lab is calling, and they're starting to give us some evidence that we don't like. And I'm just going to go over 3 examples because of time, but you look at tightly folded rock layers like this. When you look at them very, very closely and you don't see any cracks or fractures in them, it's pretty good evidence that when they were all forced to fold, they were all still soft, likely at the latter stages of the flood. Some of these are so big you can only recognize them from the air. And sometimes when you see these, I don't have my Grand Canyon diagram, but you see the layers stretched out like saltwater taffy. Fossil trees spanning multiple rock layers, especially in coal seams in England that are supposed to be between 20 and 30,000 years old. Now, how can a tree stay standing while we're slowly building up these layers around it? It can't. So that's pretty good evidence that those layers were put down quickly. Just one more here. Dinosaur soft tissue. And I'm just curious, is there anybody in here who has never heard of this before? Anybody not heard of this? The reason I'm curious is because I had never heard of it myself until about 4 years ago. Couldn't believe it. But starting in the late 1990s, did you know that paleontologists have been starting to find dinosaur bones that are not only not fully fossilized, but when you cut them open, they're finding traces of red blood cells, microscopic traces of soft and stretchy tissue, protein molecules, even sections of the very fragile DNA molecule. And scientists are racking their brains today, trying to figure out how they can be at least 65 million years old, because they're saying this stuff doesn't preserve. This stuff just doesn't last. This is organic tissue. But these are surely animals that perished in the flood. That's what we would say. Okay, now, I'm just going to point you to a website, and you have this in your notes. On top of this problem evidence for millions of years, there's actually a ton of evidence out there that is positive evidence for a young Earth. And here you can see 100 examples. This takes you to articles that have been written by scientists that are highly educated, highly qualified, highly respectable scientists who are serious about doing research in this area, because they've come to believe that, hey, I think we've been wrong all along. It looks like maybe the Earth is young after all. Okay, so I'd encourage you to take a look at that. Next big question is millions of years. Exactly how did you arrive at that? Okay. If it's somebody's guess, we know it could be a bias. If it's due to radiometric dating, we know it's unreliable. In December, Jeannie and the kids and I drove out to visit the Grand Canyon, and we had a great time. And we went to see some of the areas just east of the Grand Canyon, Painted Desert, Petrified Forest. And we were in the visitor center at the Petrified Forest, and I was talking to the ranger that was there, and he was showing me a book, and I was looking at this book, and it had all this neat artwork of all the dinosaurs in the area, beautiful glossy color pictures, and in the margins was a scale of millions of years on all throughout the book. And I was just looking at it, and I just commented to him. I said, gosh, I wonder how we get such accurate numbers in millions of years there. And he didn't even hesitate. He said, I have no idea. So, you never know what you're going to get when you just ask the question. Interesting stuff. Well, let's take a look at the fossil record now, and we'll see what kind of evidence that is. If we look at the fossil record today, what does it show today? Because now, if we think about evolution, we would expect that the fossil record would be a very detailed story of the history of evolution of life on Earth, wouldn't it? As we go from very simple organisms way, way down at the bottom, up through many, many gradual changes in the different rock layers, up to the more complex animals at the top. So what does it show today? Well, it shows sudden appearances of animals fully formed, like birds. Birds show up as full-fledged flyers. There's nothing starting to look like a bird. Same thing with turtles and bats. We have long periods of no change for many animals. We have in the dinosaur rock layers, as old as 225 million years old, supposedly, we have owls, we have penguins, we have parrots, we have badgers, we have beavers, 100 different kinds of mammals that really haven't changed very much since then. We see extinction, as perhaps different animals have gone out to different habitats and started to adapt according to natural selection. And maybe they've been there adapting for a long, long time, so they're starting to look pretty weird. But they're gone now. They didn't make it. But most notable in the fossil record today is this absence of these gradual forms that go from a major kind of animal to another up through the rock layers, like from amphibians to reptiles and reptiles to birds or reptiles to mammals. And Charles Darwin recognized this. He devoted a whole chapter in his book to it when he said, "Why is not every geological formation and every stratum full of such intermediate links?" He said, "Geology assuredly doesn't reveal any such finely graduated organic chain." And this is the most obvious and serious objection which can be urged against the theory. So it's pretty well known. Now, Darwin thought that in his day we just hadn't found that many fossils yet. But around 150 years later, and we have millions of fossils in museums all around the world. And in '04, just 11 years ago, 12 years ago, National Geographic comes out with this article here, and they say, "Illuminating but spotty, the fossil record's like a film of evolution with 999 out of 1,000 frames lost." So the reality today is that the fossil record is not evidence for evolution. Not at all. Now, what's interesting is that we'll still hear claims. We'll hear, "What are you talking about? They're everywhere. Are you crazy?" And the thing to do is ask for the examples, because it's always the same handful of examples that come up time and time again, and they're highly challenged within science. And what you do is you go into creation.com or Answers in Genesis, where they have a Google-like search field, and you type it in, and you'll find the truth about those. I mean, let's look at human evolution, for example. The high school textbooks are filled with human ancestors. Did you know that? There's a lot of them. But they always end up being fully ape, fully human, or frauds. Because if you can discover one, you're going to be rich and famous forever. And all you need to do is convince your colleagues that, depending on what you found, it's a human ancestor. And you're set for your retirement. So there's a lot of incentive out there. But let's take a look at Neanderthal, for example. National Geographic again. Now, I don't know about you guys, but that's not the Neanderthal that I remember growing up. You know, he was more like an ape and had a club. Why? Well, because new evidence is showing everybody that Neanderthal was highly intelligent. They used language, they used tools, they played musical instruments, they buried their dead, and the ladies used cosmetics. They were fully human. They were just a people group that lived after the flood in different parts of Europe and Asia. Here's a tree. I got this one out of a high school textbook, and I like to tell our students that, you know, we'll see these trees in museums and whatnot, and some of them are very sophisticated and very colorful with beautiful artwork, but if we look at this one, can you see that there are no animals in the junctions of the tree? Why? They don't exist. They're not supported in the fossil record. And I like to tell our students that, hey, anybody can cut and paste pictures of animals and put them on a white sheet of paper and draw colorful lines in between them, but that's just somebody's imagination. We need to understand that. So the next big question for evolution is, where are all the transitional fossils? If we're going to be honest, there should be thousands and thousands and thousands and thousands of them. It shouldn't be a question, but they're all missing. Okay. How do you know that? Are you looking at a fact that's already been interpreted from the evidence? See if you can get to the evidence. Could the source be biased? Where does all the information and DNA come from? There's no good answer for that. Millions of years, how did you get that? And where are all the transitional fossils? Now I'm just going to wrap it up the next 5 to 10 minutes, with why I think all this is important. Now I know that the age of the earth can be a very sensitive issue, even among Christians. But nowhere do I see anybody saying that a belief in the age of the earth is an essential Christian doctrine. In other words, can somebody, think that millions of years are possible and still be saved? And the answer is yes. Okay. But when I see somebody trying to fit millions of years into Genesis, I would ask why. Because first of all, when we read it, it's awkward, isn't it? That's not what we get from a plain reading of Genesis. And I think that when we tend to do that, we think we should get millions of years in there somehow. It's because it's kind of easy for us to get convinced that maybe science has proven it. Because we hear it all the time, don't we? So that must be what's going on. They must fit in there somewhere. But science hasn't proven it at all. And some would say that if we try to do that, we're actually doing harm to the integrity of the Scriptures and even the gospel message. And I want to explain how. We know that in Genesis, when God created everything, it was a perfect paradise, right? There was no violence, there was no suffering, there was no disease. And on day 6, God surveyed all of creation and said, it is not just good, but very good. We also know that when Adam and Eve chose to sin and take life on their own terms against God's wishes, that's when sin and all of its consequences came into the earth for the first time. That's when violence and suffering and even death. The Bible's very clear that Adam's sin is what brought death into creation. Romans 5:12. When Adam sinned, sin entered the world, and Adam's sin brought death. So death spread to everyone, for everyone sinned. Okay? Now, if evolution is true, then the picture looks more like this. Lots and lots of dead things before Adam and Eve. Violence, suffering, disease. Paleontologists have been able to detect different diseases in bones, like osteoporosis. And this would include about 100,000 years of Stone Age human skeletons. Okay? Now, if this was all part of creation and nature, then it would mean that when Adam sinned, his sin didn't cause these things. And so his sin is kind of insignificant, isn't it? And if Adam's sin is insignificant and his sin isn't what brought all of these consequences into the world, then why do we need a Savior? Do you see how that does some damage to the gospel message? One atheist put it this way. He said, the most devastating thing, though, that biology did to Christianity was the discovery of biological evolution. Now that we know that Adam and Eve never were real people, the central myth of Christianity is destroyed. And if there never was an Adam and Eve, there never was an original sin. If there never was an original sin, there is no need of salvation. If there is no need of salvation, there is no need of a Savior. And I submit that puts Jesus, historical or otherwise, into the ranks of the unemployed. I think that evolution is absolutely the death knell of Christianity. See how important this is? And my message is, look, I don't think we need to believe in millions of years because I don't think it's been proven. And if we can't expect our kids to believe what we read in Genesis 1 and 2, how can we expect them to believe the rest of the Bible? All right. Well, I'm going to wrap it up in 5 minutes here now, a little bit less, tell you a little bit about myself. Remember that geology class I took in college? I graduated from college, and for a long, long time, I never thought about that. I believed in the Bible, but when it came to that stuff, if somebody were to ask me, Greg, what do you think of that stuff? I would have said, I don't know. I don't know what to think. But now, I would say, you know what, as far as I'm concerned, that stuff is wrong. Why? Because I finally got to a point in my life where I just wanted to make a decision on what I was going to believe, because it seems to me both sides were opposed to each other. And you don't want to go through life just kind of floating in between, do you? Live your whole life long without really confronting the question? You don't want to know how long it took me? It took me about 17 years that I feel like I wasted to some extent like that. Anyway, these scientists, I like science and whatnot, but I didn't know any of them personally, and to be honest with you, I didn't care. It seemed to me that they were talking a lot about evolution to justify their unbelief in God. That could be their choice. It didn't have to be mine. The Bible, on the other hand, well, I didn't really know much at the time, but I figured, hey, scholars have probably been challenging what the Bible says for a long, long time, hundreds and even thousands of years. And now I know that it's true. It's really been criticized a lot. But I figured, if there's anything that I can believe in to be really the truth about the world around me, it's got to be the Bible. So one day I just made a decision that if the Bible says it, as far as I'm concerned, it's true. And if there's anything opposed to that, as far as I'm concerned, it's wrong. Not just what I believed in, what I read in Genesis, but the whole thing. The problem with sin in the world and why Christ had to come to set us right with God, and the importance of trying to get sin out of our lives the best we can, that's repentance. And I'll tell you what, when I did that, it's incredible how my life changed. Not overnight, but over the course of a few months, I really began to sense the presence of God in my life. I developed a growing desire to read my Bible because I knew I had the truth. There was no question about it. I knew. And circumstances were developing in my life at the time that were just beyond coincidence. It wasn't always easy for me, but I started to develop a sense that from now on, God was going to take care of me. And my own personal opinion these days is that evolution might be for people who've already decided that they don't want to believe in God. Sadly. But I'm not alone in that. Richard Dawkins, a very outspoken atheist, has said, Darwin made it possible to be an intellectually fulfilled atheist. In other words, if you don't want to believe in God, that's okay, no problem. Look to Darwin. It can be a pretty good explanation as to how we got here. But the problem is the science doesn't support it anymore. It's just a story of how we got here, how we could have gotten here if there is no God. And it's not very well supported anymore. Do you know that the Bible mentions this stuff? Paul tells Timothy, he says, "For the time will come when they will not endure sound doctrine." Are we talking about the creation doctrine? "But they will turn their ears away from the truth and be turned aside to fables." And I'm going to suggest that the entire structure, the entire framework of evolution is a fable. So what do we do? What do we do about it? Well, when we're talking to students, I encourage them, well, go ahead and learn all about evolution, in your classes, and listen to your teachers. But learn about the other side, because you're not going to get that like in the courtroom. You're not going to hear the problem evidence. Remember? Challenge your teachers every once in a while. Be friendly, and know that you may not get very far because they may not want to talk about it. In fact, I don't think they're allowed to in science classes in public schools. But learn all about creation. Go into some of those resources that we've got, and it's incredible what's going on out there. And I am super excited about this stuff. I think I mentioned before last week, and I don't know why everybody's not talking about this stuff, but that's just me. The reason is because I am convinced that as real science keeps going, and it goes so fast, doesn't it? It's just going to continue to confirm over and over again the Genesis account of creation in the Bible. So let me wrap it up with a prayer, and we'll be done. Okay? Heavenly Father, thank you so much that we could get together like this and talk about these truths that we read in your word. And thank you that we can find out that maybe these millions of years isn't proven, and we can just take the Bible as your word and believe it. We know that we can. Lord, I pray that you go home with all of these folks here tonight and keep them safe throughout the week and bring them back next week. And we thank you for all of these things. In Jesus' name, amen. God bless you. Good night.